Welcome to our discussion on addition and subtraction of fractions. Our three objectives are very strongly related. Adding and subtracting are pretty much the same thing, right? And then being able to solve application problems is going to involve us having to add and subtract fractions. So let's start with adding fractions. Remind ourselves of what a fraction means. All right, if a pizza is cut into 8 equal parts and you eat 3 and then your friend eats 2, haven't you eaten a total of 5 pieces of pizza out of all 8, right? You've eaten 5/8 of it, and there's your 3/8 that you ate plus the 2/8 that your friend ate, gives you the 5/8 total that the two of you ate. And that's really easy when you have common denominators, right? We have a over b plus c over b just equals a plus c over b whenever b doesn't equal 0. So anytime we have two fractions with the same denominator, right, they're both b, then we can add those fractions, and subtraction is the exact same thing. All you do is change the addition symbol to subtraction, but only when the bottoms are the same. Then it makes the math really easy. Okay, but what if the bottoms aren't the same, right? What if you have two fractions with two different denominators? Well, the only way to do that is to change them into common denominators. Now, the most let's say, widely accepted way of doing this is to come up with the least common multiple, and that becomes your least common denominator. And this is 100% a great way to do this, and it's 100% the accurate way to do this. But it's not always 100% the easiest way to do this, and that's the problem with a lot of students is they struggle with trying to find that least common multiple. Finding the least common multiple of two numbers can be tricky. If you know how to do it, keep doing it the way you're doing it. Keep finding those least common multiples and changing your fractions into the least common denominators, and life is great. But if you're struggling with that, then I have a solution that will help. Okay, what if we have mixed numbers? Well, you have to remember that a mixed number is really just a whole number plus the fraction piece, right? So 2 and a half is 2 and, right? And means plus, 2 plus a half. So 3 plus 4/5 is just 3 and 4/5, right? 8 plus 7/9 is 8 and 7/9. So anytime you have mixed numbers, you know that you can break those two pieces apart and deal with just the fraction. And the reason why we talk about this is because let's say you were asked to add two mixed numbers. Let's say you had, well, let's just take these first two, 2 and a half, and you want to add 3 and 4/5. Well, if you want to add these two things together, you're really just adding this and this, right? So this plus this. Well, can't we just add the whole numbers and have 5 plus whatever we get when we have 1/2 plus 4/5? Yep, that's exactly what happens. And so now we just have to add those two fractions. And if they end up being bigger than 1, which they will, then our answer is going to be 6 and something, right? Instead of 5 and something, because that extra 1 makes 5 into 6. Okay. Well, how do we add these two fractions? Well, you can do the least common denominator trick, or you can use my bow tie technique, which if you've seen any of my other videos on fractions, you may have seen it before, but it just means we're going to multiply bottom times top, bottom times top, bottom times bottom, and then we're going to do whatever this symbol is, right? This is an addition. So bottom times top gives us a 5. Bottom times top gives us an 8. Sorry, my pen is having a problem. There it goes, an 8. Bottom times bottom gives us 10. And we're adding here, so we're adding here, and the answer is 5 plus 8, which is 13 over 10, which of course is 1 and 3/10, right? We add that to the 5 plus 5, And our answer is 6 3/10. It's that simple. All right, here's another simple example doing the same thing. We want to add these two. We can add the two whole parts to get 7, and then we just have to add the two fractional parts, which if we do the least common denominator trick, it becomes 15/24, 14/24. You add those two together, you get 29/24. But of course, this is no good. So just like before, we have to turn 29/24 into 1 plus the extra 5/24. Add the 1 and the 7, that gives us 8, right? So we see it's the same thing over and over again. What if we have to add 3 fractions? No different, common denominator for all of them, or you could do the bow tie technique for all of them, right? Bow tie these two together, get an answer, take that answer, bow tie it with a third one, get your final answer. All you have to do is possibly reduce at the end. Right? So for instance, we know that 3/4 and 5/8 has a very simple common denominator of 8. Really all we need to do is multiply this one top and bottom by 2. But if you didn't do that, and you just did 8 times 3 was 24, 4 times 5 was 20, and the bottom 4 times 8 is 32, you're now going to get something over 32 when really it should have been something over 8. Well, 32 is just 8 times 4. So all that's going to happen is whatever the number on top is, it's going to be divisible by 4 so that your answer comes back down to 8. So in the end, when you do the bow tie technique, you always have to check and see if the answer needs to be simplified, if it needs to be reduced. And I think reducing is a lot easier than trying to find a least common multiple. So that's really the payoff. That's I should say the trade-off for using the bow tie technique. Doing the least common multiple technique means the answer you get is the answer you want. You don't have to reduce it. It's just done. When you do the bow tie technique, often, not always, but often the answer you get needs to be simplified. So either you spend some time in the beginning finding that least common multiple and then multiplying each fraction by different numbers, top and bottom, right? So this first one gets multiplied top and bottom by 8, which gives you this. The second one gets multiplied top and bottom by 10, which gives you this. And then, see, I'm even screwing it up. And then the last one gets multiplied top and bottom by 5, which gives you this, so that they can all be over 40. And then you can add them together and you don't have to do any reduction. Well, to me, there's just a lot of places where you can have a brain fart, where you can be thinking 2 steps ahead and think this times 5 instead of 10 like I just did, and that kind of stuff. So it's safer, I think, to just do the bow tie technique, get an answer, and then simplify that answer, because simplification is something we don't normally make mistakes with, rather than trying to find a number to multiply this by, a number to multiply this by, a number to multiply this by. Make sure that you've actually figured out those 3 numbers correctly, then make sure that you do all of that math correctly. You see, there's many more steps. There's a lot of places where you can make mistakes. So in my experience, the bow tie technique leads to fewer mistakes, and that's what we're really all about, is minimizing our mistakes. All right, subtracting fractions, I'm not going to spend a lot of time on this because we learned how to add fractions, we learned how to subtract fractions, because it's the same darn thing, right? As long as the bases, the bottoms are the same, we can do the math. Simple example where the bottoms are the same. What if the bottoms aren't the same? Well, we got to do the same thing. We got to do the least common multiple trick, right? What if they're mixed numbers? We got to do the least common multiple trick. It's all the same thing, whether it's addition or subtraction. The only difference is when we're subtracting mixed numbers, you have to realize that you're subtracting that whole mixed number. And it's kind of a distribution problem, right? 9 minus 2 is 7, but then you also have to do this part minus this part and then see what's left over, right? So you're doing subtraction in pieces, and that can lead to some trouble. So just take it a little slower when you're doing subtraction. All right, trying to figure out if something is a solution of something, well, that you're just plugging things in. So I'm not going to spend a lot of time on that. We've done this a million times with other types of equations. Just plug in 3/2 for your W. Of course, to figure out what this is, you got to do a common denominator, comes down to here. They're the same, so we see that it is a solution. All right, last example will be an application problem. They tell us the length of a football, a regulation NCAA football, has to be no less than 11 7/16 and no more than 10 7/8. Well, that's obviously wrong. Those numbers are in the wrong place. All right, that makes more sense. No less than 10 7/8, no more than 11 7/16, i.e. a fancy way of saying it's got to be somewhere in between those two numbers. There's my minimum, there's my maximum. The answer is, what's the difference between the minimum and maximum? We're just finding the difference between those two numbers. So we take the maximum minus the minimum from it. This number minus this number, set them up with common denominators. Because this fraction is bigger than this fraction, right? Because 14 is bigger than 7. We have to borrow 1 from here. So we take one whole number away from the 11, which makes it a 10, which gives us 16 sixteenths to add to this. 16 sixteenths, right, plus 7 gives us 23 total sixteenths. 10 minus 10, those go away. 23 minus 14 gives us 9, and those two numbers are 9 sixteenths away from each other. All right, that's it for adding and subtracting and really comparing fractions, which we already learned, but it's the same thing. They all use the bow tie technique.